For those of you that missed the lesson today, this is a quick trip through the notes that we did today. Please notice the notes do not have the theorems in them. They are just the examples. So you need to make sure that your exploration has the theorems correctly filled in. We went over that in class. But that's important because otherwise you're not really sure why I'm doing this. So we're looking at similarity in right triangles. A point I emphasized is that you please remember that this only works. You have to remember the if part of the theorem. It has to be a right triangle with an altitude drawn to the hypotenuse. You tend to start to see pictures like this and then assume any time an altitude is drawn that these relationships exist, and that's not the case. It has to be a right triangle because then you have the similarity that we have proven before. So in here, we'll start with A and identify what A is. A is a leg of the large triangle. See the large triangle there? So look in your theorems in your packet and see if you see something about the leg of the large triangle. And what you should see is that the leg of the large triangle is the geometric mean between a segment of the hypotenuse, the segment adjacent to it, it's the segment that touches it, the one you're looking for, and the whole hypotenuse, which in this case is 10. So since A is the geometric mean, that's the part I'm going to write twice. Okay, so I write A twice. Then you can write 3 and 10. It really doesn't matter which order. Properties of proportions say that this could look the same. So when you do that, see if I can make all this look the same, you'll get A squared equals 30, and so that means A equals, I don't know what that is, the square root of 30. Okay. Then we'll do something similar. B is another one where it is the leg of the large triangle. So we can do something very similar where B is the geometric mean. So you write that part twice. Between the segment that touches it, in this case 7, and the whole hypotenuse, which we already found was 10. And you'll solve that, and you'll get B squared equals 70, and therefore B equals the square root of 70. And lastly, we'll look at H. Now H is a little different. H is the altitude drawn to the hypotenuse. So this is using a different theorem. In that theorem, it says the altitude drawn to the hypotenuse of a right triangle is the geometric mean. So again, the altitude is the part we write twice because that one's the geometric mean. And it's the geometric mean between the two segments. So we're going to write 3 and 7. And then cross multiply to solve. So you get H squared equals 21. So H equals the square root of 21. Okay, so we found each of them, each value here. We're going to work that again over here. Notice the big triangle is a right triangle, and this is an altitude drawn to the hypotenuse. Again, very important that you recognize that before you attempt to do the geometric mean. So I'm going to start over here, and I have 6. 6 is the leg of the large triangle. The leg of the large triangle is the geometric mean. So this time I'm going to write 6 twice because that's what the leg of the geometric mean, that's the leg of the large triangle. So 6 is the geometric mean between the segment that touches it and the whole hypotenuse. So between W and 18. Okay, cross multiply, you'll get 18W equals 36. So W equals 2. All right, now that we know W equals 2, it's pretty easy to find x. X is just going to be 18 minus 2, so now we know x is 16. Okay, so we have w and we have x. To get y, well, that's the altitude. The altitude is the geometric mean between the segments of the hypotenuse. So again, as you say the theorem, whatever you say is the geometric mean, that's what's written twice. So in this case, that is the variable. I don't want you thinking it's always the variable. Between 2 and 16, that's y squared equals 32. It's hard to write with this. And so y equals 4 root 2. That's the simplified version of the square root of 32. And last, I'll do z. Z is a leg of the large triangle. So z is the geometric mean between 16, that's the segment of the hypotenuse that touches it, and the whole hypotenuse, 18. Okay, well that gives me z squared equals, I'm not going to multiply that out because it's going to be hard for me to simplify that number. Again, some of you can do that in your head, so go ahead. Whatever you do, you should end up with z equals 12 root 2. Okay, there's a third page of examples, but I was just going to get through those to give you some examples of what to look for. Okay, again, focus on what it is. What's the geometric mean? That's the part that's written twice. Sometimes, as in the red, it's a number. Sometimes it's a variable. But as long as you have your ratios set up, you're fine. If you can't remember the geometric mean, you can look for the similarities and set the corresponding parts up. The geometric mean tends to make that a little easier than working it in that direction. So please work on the homework, and when you come next time, we'll talk about the Pythagorean theorem.